Hey, in the previous lesson, we've written our first Helm chart and learned what charts and releases are. The only problem with this chart is that it's static. It's not too different from just having a YAML file applied with kubectl. The only benefit we get from using Helm is the release tracking and rollbacks. But Helm is much more than this, and in this lesson, we will learn about another core feature of Helm, templating. Let's start with the general idea of templates. Imagine you need to create a lot of very similar files. For example, PDF invitations to a party. Each PDF is more or less the same, the only difference being the name of the person that you want to invite. To avoid creating each PDF from scratch, you could create a special PDF file that contains all the common content of the invitation, but leaves an empty area for the guest name. This file is a template. To create a new invitation, you need to take the template of an invitation and input some information about the guest. This process of providing information to the template and receiving a final document is called a template processing. In this situation, you become a template processor. Templating in programming is not much different from what I just described, but naturally a bit more computer-oriented and a bit more powerful in terms of how complex your templates can be. Let's get back to our pgadmin chart to see how templating works in Helm. We have two templates in the templates directory, for the deployment and for the service. We can ask Helm to render the final files from these templates by running help-template command. The output that you see here is exactly what Helm will apply to the Kubernetes cluster. When we run helm install or helm upgrade commands, Helm will first process the templates and then send the result to the Kubernetes API. Those are not really templates because we never specified which parts of these files should change depending on our inputs. Let's fix that. The first thing that I want to make dynamic is an environment label on each resource. I want to see if this resource belongs to the staging or to the production environment. The way Helm templates can be made dynamic is by referencing variable values. If you've used Terraform, then Helm values are exactly the same concept as Terraform variables. The variable can be referenced by the name like this. We need to type two opening curly braces, then a special keyword .values, then, after another dot, the name of the variable we want Helm to insert in this part of the template, and finally, two closing curly braces. The name of the variable can be anything you want. Let me now copy this label to a few other places inside our templates. Now let's run Helm template again. We can see that the new label env is empty because we did not set any value for our env variable. There are multiple ways to do this. We can supply values directly over the command line with the set argument followed by the variable name and the value. Now we see that the label got the proper value inside our template. We can also create a special values file and let Helm pick values from there. Let me create a values.yaml file and define the env value in there. If I run Helm template again, I will see staging. This is because Helm charts always load the file named values.yaml by default. I can create another values file, for example values.production.yaml, and override env to be production. I can then specify this values file when running helm template.--values values production.yaml. Helm will load both values files, but the production one will win over the default one. We can reference values anywhere inside the template file. Under the hood, Helm is using a template processor from Go programming language, so most of the things Go templates can do, Helm can do as well. Let's make the names of our resources dynamic by adding env as a suffix. And now let's run Helm template again. Now that names depend on the env variable, we can deploy this chart twice to the same Kubernetes namespace. I will deploy first the staging one with default values, and then the production one. Production one didn't work because, of course, I need to specify the production values file. If we inspect the list of running pods, we will see two independent pgadmin pods. Let's extend our templates a bit more and use conditional statements. I want to run 3 replicas of pgadmin in production and only 1 replica in staging. To do this, I add a simple if statement in the deployment YAML like this: if equals values.env and production, render replicas 3, else render replicas 1. Now let's render the template again. There are 2 weird empty lines before and after the replicas. It won't break our chart, but it would be nice to get rid of this. To do this, we need to add a minus sign after the opening curly braces. This way, Helm template processors knows that it should not insert empty lines instead of if, else and end statements. Let's confirm empty lines again. And now let's upgrade our production chart again. And check the list of running pods. As expected, we have 3 production pods running. Thanks to the power of Go templates, Helm charts become extremely flexible and powerful. We just saw the very basics of templating in Helm, but you can do much more complex things. It supports everything you would expect from a fully featured templating tool: loops, comparison operators, complex data structures, dozens of useful features, as well as the way to define your own functions and help us. The best source of information on all of these templating capabilities is the official documentation of Helm. In the next lesson of this course, we will look at the more advanced example of using Helm. We will learn how to use third-party chats, including the dependency management between charts. Don't forget to subscribe to our channel and press the like button. Thanks for watching!